Question 1. To address the challenge of ensuring that all virtual machines provisioned through VMware vRealize Automation 8, 1. Adhere to organizational security baselines and relevant industry compliance standards. Which of the following approaches best integrates security and compliance into the automated deployment lifecycle? Option A. Implementing automated security and compliance validation checks directly within vRealize blueprints and approval workflows, leveraging event broker services and custom resources to enforce policies before deployment. Option B. Disabling vRealize approval workflows for critical resource deployments to expedite the provisioning process and meet aggressive service delivery timelines. Option C. Conducting comprehensive security scans and manual compliance audits only after virtual machines have been fully provisioned and deployed into the production environment. Option D. Focusing security controls solely on network-level configurations and perimeter defenses, assuming that internal system configurations within deployed virtual machines will be managed separately. The correct answer is A. Implementing automated security and compliance validation checks directly within vRealize blueprints and approval workflows, leveraging event broker services and custom resources to enforce policies before deployment. Explanation. Scenario analysis. This scenario presents a common challenge in cloud automation environments, balancing the need for rapid service delivery with robust security and compliance. The challenge lies in ensuring that the automated provisioning of resources through vRealize Automation, vRA, adheres to established security policies and regulatory requirements without becoming a bottleneck. Misconfigurations or inadequate security controls within vRealize blueprints can lead to the deployment of insecure infrastructure, exposing the organization to significant risks, including data breaches, non-compliance penalties, and reputational damage. Pressure to accelerate deployment cycles often conflicts with the meticulous nature of security and compliance validation. Correct approach analysis. The correct approach involves integrating security and compliance checks directly into the vRealize blueprinting and approval workflows. This ensures that security requirements are not an afterthought but a fundamental part of the resource provisioning process. By leveraging vRealize extensibility features, such as custom resources, event brokers, and integration with security scanning tools, organizations can automate the validation of security configurations, compliance checks, e.g., adherence to CIS benchmarks, specific industry regulations, and vulnerability assessments before a resource is deployed. This proactive approach aligns with the principle of security by design and compliance by design, which are critical for maintaining a secure and compliant IT posture in an automated environment. This method ensures that all deployed resources meet predefined security baselines, reducing the attack surface and the likelihood of compliance violations. Incorrect approaches analysis. One incorrect approach is to rely solely on post-deployment security scans and manual audits. This is reactive rather than proactive. It fails to prevent the deployment of insecure resources in the first place, leading to a period of vulnerability. From a regulatory perspective, this approach may violate requirements for continuous monitoring and proactive risk management, as it allows insecure configurations to exist in the production environment. Another incorrect approach is to bypass vRealize approval workflows for speed. This directly undermines the governance and control mechanisms put in place. It bypasses opportunities for security and compliance review, increasing the risk of deploying non-compliant or insecure resources. This can lead to significant regulatory penalties and audit failures, as it demonstrates a lack of due diligence and control over the deployment process. A third incorrect approach is to implement security checks only at the infrastructure level, e.g., firewall rules, without considering the security configurations within the deployed operating system or application stack, as defined in the vRealize blueprint. This creates a false sense of security, as vulnerabilities can exist within the deployed software itself, even if the network perimeter is secure. This approach fails to address the full scope of security requirements and can lead to compliance gaps. Professional reasoning. Professionals should adopt a risk-based approach, prioritizing the integration of automated security and compliance checks into the vRealize lifecycle. This involves understanding the organization's specific regulatory landscape and security policies. The decision-making process should involve 1. Identifying critical security and compliance requirements relevant to the resources being provisioned. 2. Mapping these requirements to specific vRealize blueprint components and approval stages. 3. Leveraging vRealize automation and integration capabilities to enforce these requirements. 4. Establishing clear approval gates that require successful security and compliance validation. 5. Regularly reviewing and updating these automated checks to adapt to evolving threats and regulations. This systematic approach ensures that automation enhances, rather than compromises, security and compliance. Question 2. Process analysis reveals that a financial services organization is implementing a new self-service catalog item in VMware vRealize Automation 8. 1. For provisioning virtual machines. The organization has stringent regulatory requirements regarding data encryption, network segmentation, and access control for all deployed infrastructure. The IT team needs to ensure that every virtual machine provisioned through this catalog item automatically adheres to these policies without manual intervention. Which of the following approaches best ensures compliance and operational efficiency? Option A. Embed specific security configurations directly within the vRealize automation blueprint without utilizing policy-driven extensibility. Option B. Rely on end users to manually apply security configurations to their provisioned virtual machines based on provided documentation. Option C. Manually review and configure security settings on each virtual machine after it has been provisioned by vRealize automation. Option D. Develop custom vRealize orchestrator workflows that are triggered by vRealize extensibility subscriptions to enforce security policies before virtual machine deployment. The correct answer is D. Develop custom vRealize orchestrator workflows that are triggered by vRealize extensibility subscriptions to enforce security policies before virtual machine deployment. Explanation. This scenario presents a common challenge in cloud automation environments, balancing the need for rapid service delivery with the imperative of maintaining robust security and compliance. The professional is tasked with implementing a new catalog item in VMware vRealize Automation, vRealize 8, one that will provision virtual machines. The challenge lies in ensuring that the provisioning process adheres to the organization's security policies, which are often complex and subject to regulatory oversight. A failure to properly integrate these policies into the vRealize blueprint and associated workflows can lead to security vulnerabilities, non-compliance, and potential audit failures. Careful judgment is required to select the most effective and compliant method for enforcing these policies within the vRealize framework. The correct approach involves leveraging vRealize's built-in policy enforcement mechanisms, specifically through the use of extensibility subscriptions and event broker service (EBS) subscriptions. By subscribing to relevant vRealize events, e.g., for blueprint provisioning, and triggering custom workflows that validate or modify the provisioned resources against defined security policies, the organization can ensure that all deployed virtual machines meet the required standards. This method is best professional practice because it is declarative, auditable, and integrates seamlessly with the vRealize lifecycle. It allows for centralized management of policies and ensures consistent enforcement across all deployments, thereby meeting regulatory requirements for security and governance. An incorrect approach would be to bypass vRealize policy enforcement and rely solely on manual post-provisioning checks or ad hoc scripting. This is professionally unacceptable because it introduces significant risk. Manual checks are prone to human error, are not scalable, and do not provide real-time enforcement, leading to potential compliance gaps. Relying on ad hoc scripting creates a fragmented and unmanageable security posture, making it difficult to audit and prove compliance. Another incorrect approach would be to hard-code security configurations directly into the blueprint without using policy-driven mechanisms. This lacks flexibility, is difficult to update when policies change, and does not provide the necessary audit trail for regulatory compliance. It also violates the principle of least privilege and separation of duties if the blueprint author has direct control over security configurations. The professional reasoning process should involve understanding the organization's security and compliance requirements, identifying the relevant vRealize events and extensibility points, designing custom workflows to enforce these policies, and thoroughly testing the implementation. This iterative process ensures that the automation solution is not only functional, but also secure and compliant. Question 3. The control framework reveals that a new catalog item for provisioning virtual machines in vRealize Automation 8. One must adhere to strict organizational security policies, including network segmentation and endpoint security hardening. The primary goal is to automate the deployment of these virtual machines, while ensuring that all security configurations are applied correctly and are auditable. Which of the following approaches best satisfies these requirements within the VRA 8? 1. Environment. Option A. Implement custom vRealize orchestrator workflows that are triggered by vRA extensibility subscriptions to enforce security policies before VM provisioning, utilizing property groups to define and assign security configurations to the blueprint. Option B. Rely on the cloud provider's default security configurations without any explicit enforcement within vRealize Automation. Option C. Manually review and apply security hardening scripts to each virtual machine after it has been provisioned by vRealize Automation. Option D. Configure vRealize Automation to bypass all security policy checks during the initial provisioning phase to expedite deployment, with a plan to address security later. The correct answer is A. Implement custom vRealize orchestrator workflows that are triggered by vRA extensibility subscriptions to enforce security policies before VM provisioning, utilizing property groups to define and assign security configurations to the blueprint. Explanation. This scenario presents a common challenge in cloud automation environments, balancing the need for rapid service delivery with robust security and compliance controls. The professional is tasked with implementing a new catalog item in vRealize Automation, vRA, that will provision virtual machines. The challenge lies in ensuring that the provisioning process adheres to the organization's security policies, which are often dictated by regulatory frameworks relevant to the exam's jurisdiction. The risk is that a poorly configured catalog item could inadvertently bypass security checks, leading to compliance violations and potential data breaches. Careful judgment is required to select the appropriate vRA features and configurations that enforce these policies without unduly hindering the automation's efficiency. The correct approach involves leveraging vRA's built-in policy enforcement mechanisms, specifically focusing on the integration of extensibility subscriptions and property groups by defining security policies as vRA properties and associating them with the blueprint through property groups, and then triggering custom actions via extensibility subscriptions at specific lifecycle events, e.g., before provisioning. The organization can ensure that security requirements are programmatically enforced. This approach aligns with best professional practice by embedding security and compliance directly into the automation workflow, making it auditable and repeatable. It demonstrates a proactive stance on security, ensuring that all provisioned resources meet predefined standards before they are deployed. This is crucial for maintaining regulatory compliance and mitigating risks. An incorrect approach would be to rely solely on manual security reviews after the virtual machine has been provisioned. This is a reactive measure that fails to prevent non-compliant resources from entering the environment. It represents a significant regulatory and ethical failure because it increases the likelihood of compliance breaches and security vulnerabilities going undetected until after a potential incident. Another incorrect approach would be to disable or bypass vRA's policy enforcement features to speed up the provisioning process. This is a direct violation of security best practices and likely contravenes organizational policies and relevant regulations, as it prioritizes speed over security and compliance. This demonstrates a disregard for established control frameworks and a failure to uphold professional responsibility. The professional decision-making process for similar situations should involve a thorough understanding of the organization's security policies and the applicable regulatory requirements. For implementing any automation, professionals should identify critical security controls and determine how these can be integrated into the vRA workflow. This involves analyzing the capabilities of vRA, such as policy enforcement, extensibility, and integration points. The process should prioritize a security by design approach, where security and compliance are considered from the initial stages of automation development. Regular review and auditing of automated processes are also essential to ensure ongoing adherence to policies and regulations. Question 4. Operational review demonstrates that several newly onboarded development teams are experiencing inconsistencies in the security posture of their deployed resources, deviating from established organizational security policies within the vRealize Automation 8.1 environment. This drift is impacting compliance audits and raising concerns about potential unauthorized access. The immediate pressure is to unblock these teams and ensure their services can be deployed without further delay. What is the most appropriate course of action to address this situation? Option A. Conduct a thorough audit of vRealize blueprints, custom resources, and policy configurations to identify the specific points of deviation from security policies. Remediate the identified misconfigurations through controlled changes within vRealize and revalidate compliance. Option B. Temporarily disable all security policies within vRealize for the affected projects until the development teams can be fully onboarded and their resource requirements are understood. Option C. Document the observed security policy drift and inform management of the issue, while allowing current deployments to continue as is to avoid disrupting development timelines. Option D. Implement a global, allow all rule for all new resource deployments from the affected teams to expedite their service delivery, while a long-term solution is investigated. The correct answer is A. Conduct a thorough audit of vRealize blueprints, custom resources, and policy configurations to identify the specific points of deviation from security policies. Remediate the identified misconfigurations through controlled changes within vRealize and revalidate compliance. Explanation. Scenario analysis. This scenario presents a common challenge in cloud automation environments, balancing the need for rapid service delivery with the imperative of maintaining robust security and compliance. The pressure to onboard new development teams quickly, coupled with the inherent complexity of vRealize automation, vRA configurations, creates a risk of misconfigurations that could lead to security vulnerabilities or non-compliance with internal policies. The challenge lies in identifying the root cause of the observed drift and implementing a sustainable solution without unduly hindering development velocity. Correct approach analysis. The correct approach involves a systematic investigation of the vRealize environment to pinpoint the exact source of the security policy deviations. This includes analyzing the blueprint configurations, custom resources, policies, and any integrations with external security tools. The focus on identifying the specific configuration drift and then remediating it through controlled changes within vRealize, followed by revalidation, represents best professional practice. This aligns with the principles of least privilege, secure by design, and continuous compliance, which are fundamental to responsible cloud operations and are implicitly supported by the operational guidelines and security best practices expected in a professional VMware environment. The emphasis on understanding the why behind the drift ensures that the remediation is effective and prevents recurrence. Incorrect approach is analysis. Disabling security policies entirely, even temporarily, represents a significant regulatory and ethical failure. It directly contravenes the principle of maintaining a secure posture and exposes the environment to unacceptable risks. This action would likely violate internal security policies, industry best practices, and potentially external compliance mandates, leading to data breaches, reputational damage, and legal repercussions. Implementing a blanket, allow all rule for new blueprints is another critical failure. This approach completely bypasses security controls and introduces a severe vulnerability. It demonstrates a lack of understanding of security principles and a disregard for the potential impact of unauthorized access or resource misallocation. This would be a direct violation of security best practices and likely contravene any established compliance frameworks. Ignoring the drift and hoping it resolves itself is a passive but equally damaging approach. It signifies a failure to proactively manage the environment and address identified risks. This inaction can lead to the escalation of security vulnerabilities and compliance issues, making remediation more complex and costly later. It also demonstrates a lack of professional accountability for the operational integrity of the vRealize platform. Professional reasoning. Professionals facing this situation should adopt a structured problem-solving methodology. First, clearly define the observed issue, security policy drift. Second, gather all relevant data by thoroughly reviewing vRealize configurations, audit logs, and any associated security tooling. Third, hypothesize potential causes for the drift, considering blueprint design, policy enforcement mechanisms, and user roles. Fourth, test these hypotheses through controlled investigations. Fifth, develop and implement a remediation plan that addresses the root cause, prioritizing security and compliance. Finally, establish ongoing monitoring and validation processes to prevent future drift. This systematic approach ensures that solutions are effective, sustainable, and aligned with professional and regulatory expectations. Question 5. Consider a scenario where a business unit urgently requires the deployment of a new application service within the VMware vRealize Automation 8.1 environment to meet a critical market opportunity. The pressure is high to deliver this service within a compressed timeframe, and the business unit is requesting expedited provisioning, potentially bypassing some standard governance checks. The IT operations team is concerned about maintaining compliance and security standards, which approach best balances the need for rapid deployment with the imperative of adhering to regulatory and organizational policies. Option A. Implement the service using a pre-approved, hardened blueprint that includes all necessary security configurations and compliance tags, and utilize vRealize built-in approval workflows to ensure business unit sign-off on the deployed service's compliance aspects before it becomes operational. Option B. Deploy the service using a custom blueprint developed by the business unit's technical lead, bypassing the standard IT governance review process to save time, with the understanding that it will review it for compliance later. Option C. Prioritize the functional requirements of the application service and deploy it with minimal configuration, deferring all security hardening and compliance tagging until a later, unspecified date when resources become available. Option D. Provision the service immediately using a generic blueprint to meet the deadline, with a plan to retroactively apply security configurations and compliance tags after the service is live and the immediate pressure has subsided. The correct answer is A. Implement the service using a pre-approved, hardened blueprint that includes all necessary security configurations and compliance tags, and utilize vRealize built-in approval workflows to ensure business unit sign-off on the deployed service's compliance aspects before it becomes operational. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid service delivery and maintaining robust security and compliance within a VMware vRealize Automation (vRA) 8.1 environment. The pressure to onboard new services quickly can lead to shortcuts that bypass established governance and security protocols, potentially exposing the organization to risks. Careful judgment is required to balance agility with the non-negotiable requirements of data protection and regulatory adherence. The correct approach represents best professional practice because it prioritizes a structured, policy-driven deployment process. By leveraging vRealize built-in capabilities for policy enforcement, such as blueprint validation, approval workflows, and resource naming conventions, the organization ensures that all deployed services meet predefined security and compliance standards from the outset. This proactive approach minimizes the risk of introducing vulnerabilities or non-compliant configurations, aligning with the principle of security by design and demonstrating due diligence in managing cloud resources. Adherence to established governance frameworks, even under pressure, is a cornerstone of professional responsibility in IT operations. An incorrect approach that bypasses the standard blueprint review and approval process for expediency is professionally unacceptable. This failure represents a significant regulatory and ethical lapse. It directly contravenes the principles of responsible IT governance, which mandate that all changes and deployments be subject to scrutiny to ensure they meet security, compliance, and operational requirements. Such a shortcut could lead to the deployment of services with misconfigurations, unpatched vulnerabilities, or data handling practices that violate privacy regulations, exposing the organization to legal penalties, reputational damage, and operational disruptions. Another incorrect approach, focusing solely on functional requirements without considering resource naming conventions or tagging policies, also constitutes a regulatory and ethical failure. While the service might function as intended, the lack of proper metadata makes it difficult to track, audit, and manage resources effectively. This hinders compliance efforts, as it becomes challenging to demonstrate adherence to data residency requirements, cost allocation policies, or security segmentation rules. Professionally, This demonstrates a lack of foresight and a failure to implement best practices for resource governance and lifecycle management. Professional reasoning process for similar situations should involve a clear understanding of the organization's governance policies, security standards, and relevant regulatory obligations. When faced with pressure to accelerate deployments, professionals must advocate for adherence to established processes, highlighting the risks associated with shortcuts. If process bottlenecks are identified, the professional response should be to seek improvements to the process itself, rather than circumventing it. This involves engaging with stakeholders to streamline workflows, automate checks, and ensure that governance is an enabler of agility, not an impediment. A robust decision-making framework would involve 1. Identifying the core requirement service deployment. 2. Assessing against established policies and regulations. 3. Evaluating potential risks of deviation. 4. Communicating risks and proposing compliance solutions. 5. Escalating, if necessary, to ensure compliance is maintained. Question 6. The investigation demonstrates that a critical security vulnerability was discovered in a production environment due to a misconfiguration during the deployment of a new virtual machine blueprint within VMware vRealize Automation 8. 1. The vulnerability stemmed from the blueprint not enforcing the required network segmentation policies. To prevent recurrence and ensure ongoing compliance with internal security mandates, what is the most effective and professionally sound approach to integrate robust policy enforcement into the vRA deployment process? Option A. Implement vRA approval policies to require explicit sign-off from the security team for any blueprint that deviates from predefined network segmentation standards before deployment. Option B. Instruct the infrastructure team to manually configure network settings on each virtual machine after it has been deployed by vRA, bypassing any blueprint-defined network configurations. Option C. Conduct regular manual audits of all deployed virtual machines to identify and remediate any network misconfigurations after they have been provisioned. Option D. Focus solely on updating the blueprint to include the correct network configurations and assume that all future deployments from this updated blueprint will be compliant without additional policy enforcement mechanisms. The correct answer is A. Implement vRA approval policies to require explicit sign-off from the security team for any blueprint that deviates from predefined network segmentation standards before deployment. Explanation. The investigation demonstrates a common challenge in cloud automation. Ensuring consistent and secure deployment of resources across different environments while adhering to evolving security policies. The professional challenge lies in balancing the speed and agility offered by vRealize Automation, vRA, with the imperative to maintain compliance and prevent unauthorized access or misconfigurations. This requires a deep understanding of vRA's capabilities, the underlying infrastructure, and the relevant regulatory landscape. The correct approach represents best professional practice because it directly addresses the core requirement of policy enforcement within the vRA framework. By leveraging vRA's built-in policy capabilities, such as approval policies and lifecycle state policies, administrators can automate the enforcement of security and compliance rules at critical stages of the resource lifecycle. This proactive, automated approach minimizes human error, ensures consistent application of controls, and provides an auditable trail, which is crucial for regulatory compliance. This aligns with the principle of least privilege and defense in depth, fundamental tenets of secure cloud operations. An incorrect approach that relies solely on manual review of deployed resources after provisioning fails to meet the professional standard. This method is reactive, inefficient, and highly susceptible to human oversight. It introduces significant security risks by allowing potentially non-compliant resources to exist in the environment, even temporarily. From a regulatory perspective, this approach often leads to audit failures and potential penalties due to the lack of automated, verifiable controls. Another incorrect approach that bypasses vRA's policy engine and directly modifies infrastructure configurations outside of vRA introduces significant drift and undermines the automation's integrity. This creates a shadow IT environment where the state of resources is not accurately reflected or managed by the central automation platform. This lack of centralized control and visibility is a major security and compliance risk, making it impossible to reliably audit or enforce policies. It violates the principle of a single source of truth for infrastructure management. A further incorrect approach that focuses only on the initial provisioning of resources without considering ongoing management and lifecycle events is incomplete. Security and compliance are not static. They require continuous monitoring and adaptation. Failing to implement policies that govern resource updates, decommissioning, or access changes leaves the environment vulnerable to evolving threats and policy violations. Professional decision-making in this context requires a holistic view of the resource lifecycle and the implementation of automated controls at each stage, guided by a clear understanding of the organization's security posture and regulatory obligations. Question 7. Upon reviewing the access requirements for a new development team onboarding to vRealize Automation 8, 1. It's clear they need to provision virtual machines and deploy pre-approved application stacks. However, they should not have the ability to modify core infrastructure components or access sensitive production data. Which of the following approaches best adheres to security best practices and regulatory compliance for managing their access? Option A. Create a custom role with specific permissions allowing the provisioning of approved catalog items and virtual machines, and assign this role to the development team members. Option B. Assign a single, highly privileged role that grants broad permissions for all resource types to the development team, assuming they will exercise caution. Option C. Develop one comprehensive custom role that includes every conceivable permission a developer might need across all environments, and assign it to the entire team. Option D. Grant all members of the development team full administrative access to the vRealize automation environment to ensure they have the flexibility to manage their deployments. The correct answer is A. Create a custom role with specific permissions allowing the provisioning of approved catalog items and virtual machines, and assign this role to the development team members. Explanation. Scenario analysis. This scenario presents a common challenge in cloud automation environments where multiple teams require access to sensitive infrastructure resources. The professional challenge lies in balancing the need for self-service provisioning with robust security controls and compliance requirements. Improperly configured access can lead to unauthorized resource modification, data breaches, or violations of internal policies and external regulations. The complexity arises from the dynamic nature of cloud resources and the need for granular control over who can access and manage what, especially when dealing with shared environments. Correct approach analysis. The correct approach involves leveraging VMware vRealize Automation's role-based access control (RBAC) capabilities to create distinct roles with specific permissions. This aligns with the principle of least privilege, a fundamental security best practice and a common regulatory requirement across many industries. By assigning users to roles that grant only the necessary permissions for their tasks, e.g., a developer role that can deploy pre-approved blueprints but not modify infrastructure configurations, you minimize the attack surface and reduce the risk of accidental or malicious misconfigurations. This granular control ensures that users can perform their duties efficiently without compromising the security and integrity of the underlying infrastructure, directly supporting compliance with security standards that mandate access control. Incorrect approaches analysis. Granting all users within the development team administrative access to the vRealize automation environment is a significant security and compliance failure. This violates the principle of least privilege, exposing the environment to a high risk of unauthorized changes, accidental deletions, or security misconfigurations by individuals who do not require such broad access. This approach is professionally unacceptable as it directly contravenes security best practices and would likely fail audits for access control and segregation of duties. Assigning a single, highly privileged role to all users in the development team, even if it's not full administrative access, is also problematic. If this role grants permissions beyond what is strictly necessary for their development tasks, e.g., the ability to provision any type of resource, including production databases, without approval, it still poses a security risk. This approach fails to implement granular control and can lead to the provisioning of inappropriate or insecure resources, potentially violating compliance policies related to resource deployment and management. Creating a single, overly broad custom role that encompasses all potential permissions a developer might ever need, and assigning it to everyone, is another flawed strategy. While it might seem convenient, It bypasses the opportunity for fine-grained control and introduces unnecessary risk. If a user's role changes or their responsibilities shift, managing these broad permissions becomes cumbersome and error-prone, increasing the likelihood of security gaps or compliance issues. This approach lacks the agility and precision required for effective security and compliance in a dynamic cloud environment. Professional reasoning. Professionals should approach access control in vRealize automation by first identifying distinct user groups and their specific operational needs. This involves understanding the principle of least privilege and how it translates into practical permission sets. The decision-making process should prioritize creating custom roles that map directly to these identified needs, ensuring that each role grants only the minimum necessary permissions. Regular review and auditing of these roles and user assignments are crucial to maintain security posture and compliance. When faced with requests for broader access, professionals must critically evaluate the necessity and potential risks, advocating for more granular solutions where possible, rather than defaulting to overly permissive configurations. Question 8. Strategic planning requires a comprehensive approach to integrating security and compliance with an automated cloud service delivery. When designing a vRealize Automation 8, one solution to provision virtual machines for a regulated industry, which of the following strategies best ensures that all deployed resources adhere to strict security baselines and governance policies from the moment of creation? Option A. Relying on manual security audits and remediation efforts performed by a dedicated security team after virtual machines have been deployed. Option B. Implementing automated security and compliance checks through vRealize orchestrator workflows and vRA policies that are enforced during the blueprint provisioning process. Option C. Providing end users with broad permissions and expecting them to manually configure security settings according to organizational guidelines. Option D. Prioritizing rapid deployment speed above all else, with the understanding that security configurations can be addressed in subsequent operational phases. The correct answer is B. Implementing automated security and compliance checks through vRealize orchestrator workflows and vRA policies that are enforced during the blueprint provisioning process. Explanation. Scenario analysis. This scenario presents a common challenge in cloud automation, balancing the need for rapid service deployment with the imperative to maintain robust security and compliance. The professional is tasked with designing a vRealize automation, vRA, solution that can provision resources quickly to meet business demands, but without compromising the organization's adherence to specific regulatory frameworks. The challenge lies in identifying and implementing the correct security controls and governance mechanisms within vRA that align with these external requirements, ensuring that automation does not inadvertently create compliance gaps. This requires a deep understanding of both vRA's capabilities and the underlying regulatory landscape. Correct approach analysis. The correct approach involves a comprehensive integration of security and compliance policies directly into the vRA service catalog and blueprint design. This means leveraging vRA's extensibility features, such as vRealize orchestrator, vRO, workflows, and custom properties, to enforce security configurations, tagging, and access controls at the point of resource provisioning. By embedding these controls within the automation workflows, the system inherently ensures that all deployed resources meet the defined compliance standards. This proactive, security by design methodology is best professional practice because it automates compliance, reduces the risk of human error, and provides an auditable trail of policy enforcement, directly aligning with the principles of regulatory adherence and risk management. Incorrect approach is analysis. One incorrect approach is to rely solely on post-provisioning security scans and manual remediation. This is a reactive strategy that fails to prevent non-compliant resources from being deployed in the first place. From a regulatory perspective, this approach often leads to violations because it does not guarantee continuous compliance and can result in significant audit findings and potential penalties. It also introduces operational overhead and delays in addressing security issues. Another incorrect approach is to delegate all security and compliance responsibilities to the end users or development teams without providing them with the necessary guardrails within the automation platform. This can lead to inconsistent security postures and a lack of accountability. ethically and professionally. This abdicates the responsibility of the automation architect to ensure the platform itself promotes secure and compliant deployments. It creates a significant risk of shadow IT or unauthorized configurations that bypass established governance. A third incorrect approach is to over-engineer security controls to the point where they significantly impede the speed and agility that automation is intended to provide. While security is paramount, an overly restrictive approach can lead to business frustration and workarounds that ultimately undermine the intended security and compliance framework. This demonstrates a failure to balance competing requirements effectively, which is a core professional competency in designing enterprise automation solutions. Professional reasoning. Professionals should approach this challenge by first thoroughly understanding the specific regulatory requirements applicable to their organization. This involves consulting with compliance officers and legal counsel. Next, they must map these requirements to the capabilities of vRealize automation, identifying which controls can be automated through blueprints, VRO workflows, policies, and custom properties. A phased implementation approach, starting with critical compliance controls and gradually expanding, is advisable. Continuous monitoring and auditing of the automated processes are essential to ensure ongoing adherence and to identify areas for improvement. This systematic, risk-based approach ensures that automation serves both business agility and regulatory obligations effectively. Question 9. Examination of the data shows that both development and operations teams require self-service access to provision virtual machines and associated network resources within vRealize Automation 8. 1. The development team needs to deploy resources for testing and development in non-production environments, while the operations team requires the ability to deploy and manage production resources. Both teams need to adhere to strict naming conventions and audit trails for all deployed resources. What is the most effective approach to manage access and resource provisioning while ensuring security and compliance? Option A. Grant all users within the development and operations teams administrative privileges to the vRealize automation environment to ensure maximum flexibility. Option B. Create a single developer role and a single operations role that grants access to all available blueprints in all cloud accounts. Option C. Rely on manual verification of deployed resources by a central security team after provisioning, without implementing specific RBAC or naming conventions within vRealize automation. Option D. Assign distinct roles to development and operations teams that grant them specific permissions to provision approved blueprint types within designated projects, enforcing custom naming conventions through vRealize automation policies and blueprint configurations. The correct answer is D. Assign distinct roles to development and operations teams that grant them specific permission to provision approved blueprint types within designated projects, enforcing custom naming convention through vRealize automation policies and blueprint configurations. Explanation. Scenario analysis. This scenario presents a common challenge in cloud automation environments where multiple teams require access to sensitive resources. The professional challenge lies in balancing the need for self-service provisioning with robust security controls and compliance requirements. Granting overly broad permissions can lead to security breaches and regulatory noncompliance, while overly restrictive permissions can hinder productivity and adoption of the automation platform. The need for granular control over resource deployment and access, especially concerning sensitive data or critical infrastructure, necessitates a deep understanding of vRealize automation's capabilities and the underlying security principles. Correct approach analysis. The correct approach involves leveraging vRealize automation's role-based access control RBAC and custom resource naming conventions to enforce granular permissions and auditability. By assigning specific roles to the development and operations teams that grant them the ability to provision only approved resource types within designated projects, and by enforcing a naming convention that includes team identifiers and environment details, we ensure that 1. Access is limited to authorized users and resources. 2. Resource ownership and accountability are clearly established through naming. 3. Auditing and compliance reporting are simplified by consistent data. This aligns with best practices for cloud security and governance, ensuring that the principle of least privilege is applied effectively within the automated environment. Incorrect approaches analysis. Granting all users within the development and operations teams administrative privileges to the vRealize automation environment is a significant regulatory and ethical failure. This violates the principle of least privilege, exposing the entire automation infrastructure to potential misuse, accidental misconfiguration, or malicious attacks. It makes auditing and accountability virtually impossible, as any user could perform any action, obscuring who performed specific critical operations. This approach is fundamentally insecure and non-compliant with most data protection and security standards. Creating a single, broad developer role and a single operations role that grants access to all available blueprints and all cloud accounts is also problematic. But attempts to segment teams, it still grants excessive permissions within those segments. Developers might be able to deploy resources into production environments they should not have access to, and operations teams might be able to modify or delete resources they are only meant to manage. This lack of granularity increases the risk of unauthorized access to sensitive data or critical services, and complicates compliance efforts by making it difficult to demonstrate specific access controls for different resource types or environments. Implementing a solution that relies solely on manual verification of deployed resources after provisioning, without leveraging vRealize automation's built-in RBAC and naming conventions, is an inefficient and error-prone approach. This bypasses the platform's security features and introduces significant delays and potential for human error. It fails to proactively enforce security policies and compliance requirements at the point of provisioning, making it difficult to maintain a secure and compliant state. This approach is not a sustainable or professional method for managing access and resources in an automated cloud environment. Professional reasoning. Professionals should approach this scenario by first understanding the specific compliance and security requirements applicable to the organization's data and infrastructure. This involves identifying sensitive data classifications, regulatory mandates, e.g., GDPR, HIPAA, SOX, if applicable to the exam's implied jurisdiction, and internal security policies. Next, they should map these requirements to vRealize automation's capabilities, focusing on RBAC, blueprints, policies, and custom naming conventions. The decision-making process should prioritize a layered security approach, starting with the principle of least privilege and extending to granular access controls, resource segmentation, and robust auditing. Regular review and updates of roles, policies, and blueprints are essential to adapt to evolving threats and business needs. Question 10. Performance analysis shows that a new business-critical application requires rapid deployment into the vRealize Automation 8.1 environment. The development team has provided a set of automation scripts that have not undergone the standard security and compliance validation process. Which approach best balances the need for speed with the imperative of maintaining a secure and compliant vRealize automation environment? Option A. Integrate the application using the provided scripts, initiating a post-deployment security and compliance audit to address any identified issues. Option B. Utilize existing, pre-approved vRealize automation blueprints and workflows that are known to meet security and compliance standards, adapting them as necessary for the new application's requirements. Option C. Deploy the application using the provided scripts without immediate security or compliance checks, deferring these activities to a later operational phase to meet the urgent deployment deadline. Option D. Develop new, custom vRealize automation blueprints and workflows for the application, incorporating security scanning and compliance checks directly into the build process before deployment. The correct answer is A. Integrate the application using the provided scripts, initiating a post-deployment security and compliance audit to address any identified issues. Explanation. This scenario presents a common challenge in cloud automation, balancing the need for rapid deployment with the imperative of maintaining robust security and compliance. The professional is tasked with evaluating different strategies for integrating a new, potentially sensitive application into the vRealize automation environment. The core difficulty lies in ensuring that the automation processes themselves do not inadvertently create security vulnerabilities or violate established governance policies, which are critical for maintaining the integrity and trustworthiness of the IT infrastructure. The correct approach prioritizes a phased, security-conscious integration that leverages existing, validated automation blueprints and workflows. This aligns with best practices for secure DevOps and cloud governance, ensuring that new deployments are subject to the same rigorous security and compliance checks as existing ones. By utilizing pre-approved components and incorporating security scanning early in the process, this method minimizes the risk of introducing new attack vectors or non-compliant configurations. This proactive stance is essential for adhering to internal security policies and any relevant industry-specific regulations that mandate data protection and system integrity. An incorrect approach that bypasses standard security validation for speed introduces significant regulatory and ethical risks. For instance, deploying an application without proper security scanning or access control reviews could lead to unauthorized data access or system compromise, directly violating data privacy regulations and internal security policies. Another incorrect approach, relying solely on manual security reviews after deployment, is reactive and inefficient. This delays the identification of vulnerabilities, increasing the window of exposure and potentially leading to breaches that have severe regulatory consequences, including fines and reputational damage. Furthermore, failing to document and audit the automation process for compliance purposes undermines transparency and accountability, which are often mandated by regulatory frameworks. Professionals should employ a decision-making framework that begins with understanding the specific compliance and security requirements applicable to the data and applications being deployed. This involves consulting relevant policy documents, regulatory guidelines, and security best practices. The next step is to evaluate proposed automation strategies against these requirements. Prioritizing solutions that embed security and compliance checks throughout the automation lifecycle. When faced with pressure to accelerate deployment, professionals must clearly articulate the risks associated with shortcuts and advocate for solutions that maintain security and compliance integrity, even if it requires a slightly longer initial deployment time. This demonstrates professional responsibility and ethical conduct. Question 11. Risk assessment procedures indicate that the automated provisioning of new virtual machines via vRealize Automation 8. One must adhere to strict security baselines to mitigate potential compliance violations. Considering the need for both rapid deployment and robust security, which approach best integrates these requirements into the vRealize catalog item lifecycle? Option A. Rely solely on post-provisioning security scans and subsequent manual remediation to ensure compliance with security baselines. Option B. Bypass security configurations in the blueprint to expedite initial deployment, with a plan to address security later through separate manual processes. Option C. Embed security hardening configurations, network segmentation policies, and access controls directly within the vRealize blueprint and leverage vRealize policy engine to enforce these settings during the provisioning process. Option D. Manually apply security configurations to each provisioned virtual machine after it has been deployed by vRealize Automation. Correct answer is C. Embed security hardening configurations, network segmentation policies, and access controls directly within the vRealize blueprint and leverage vRealize policy engine to enforce these settings during the provisioning process. Explanation. Scenario analysis. This scenario presents a common challenge in cloud automation, balancing the need for rapid service delivery with robust security and compliance. The professional is tasked with implementing a new catalog item in vRealize Automation, vRA, that will provision virtual machines. The challenge lies in ensuring that the provisioning process adheres to established security baselines and regulatory requirements without unduly delaying the deployment of essential resources. The risk assessment highlights potential vulnerabilities if security is overlooked, but also the business impact of slow provisioning. This requires a nuanced approach that integrates security controls seamlessly into the automation workflow. Correct approach analysis. The correct approach involves embedding security configurations directly into the vRealize blueprint and associated policies. This means defining security hardening standards, network segmentation rules, and access controls as part of the blueprint's definition. By leveraging vRealize policy engine, specific compliance checks can be automated and enforced during the provisioning lifecycle. This ensures that every deployed VM automatically meets the required security posture from its inception, aligning with the principle of security by design. This proactive integration minimizes the risk of non-compliant deployments and reduces the burden on manual security reviews post-provisioning, thereby supporting both security and agility. This aligns with best practices for secure cloud deployments, emphasizing automation of compliance. Incorrect approaches analysis. One incorrect approach is to rely solely on post-provisioning security scans and remediation. This method is reactive and introduces a significant delay between VM deployment and its security validation. If a vulnerability is found, the VM might already be in use, increasing the attack surface and potential for compromise. This fails to meet the proactive security requirements implied by the risk assessment and can lead to regulatory noncompliance if specific security baselines are mandated from the moment of deployment. Another incorrect approach is to manually apply security configurations after the VM has been provisioned by vRealize. This negates the benefits of automation and introduces human error. Manual processes are prone to inconsistencies, omissions, and delays, directly contradicting the goal of efficient and secure automated provisioning. This approach also fails to leverage vRealize capabilities for policy enforcement and can lead to a drift from desired security states, increasing the risk of security breaches and regulatory violations. A third incorrect approach is to bypass security configurations in the blueprint to expedite initial deployment, with the intention of addressing them later. This is a direct violation of security best practices and the implied mandate from the risk assessment. It prioritizes speed over security, creating a known vulnerability from the outset. This significantly increases the risk of unauthorized access, data breaches, and noncompliance with any relevant security standards or regulations. Professional reasoning. Professionals should adopt a security as code mindset when working with vRealize. This involves treating security configurations and policies with the same rigor as infrastructure code. The decision-making process should prioritize integrating security controls into the automation workflow from the design phase. This means understanding the organization's security baselines and regulatory obligations and translating them into vRealize blueprints, policies, and workflows. When faced with a choice between speed and security, the professional should always advocate for solutions that achieve both, leveraging vRealize capabilities to automate security enforcement. If a conflict arises, the professional should engage with security and compliance teams to find an automated solution rather than resorting to manual workarounds or security compromises. Question 12. Analysis of a scenario where a development team is experiencing significant delays in provisioning new virtual machines due to the current vRealize automation, vRealize approval process, which requires manual review of each request against a complex set of security compliance checklists. The team is pressuring the automation team to expedite deployments, suggesting they temporarily disable certain security checks within vRealize to meet aggressive project deadlines. What is the most professional and compliant approach to address this situation? Option A. Temporarily disable all security compliance checks within vRealize to allow for immediate provisioning of virtual machines, with a plan to re-enable them once the project deadlines have passed. Option B. Implement a separate post-provisioning security scanning tool that runs after virtual machines are deployed to identify and remediate any compliance issues, while allowing current vRealize provisioning to proceed without modification. Option C. Advise the development team that manual review is a necessary security control and that their project deadlines must be adjusted to accommodate the existing security procedures. Option D. Enhance the vRealize blueprint policies to automatically enforce critical security configurations and implement granular approval policies that trigger only for specific, high-risk deployments or deviations from standard security baselines, thereby streamlining the approval process for compliant requests. Correct answer is D. Enhance the vRealize blueprint policies to automatically enforce critical security configurations and implement granular approval policies that trigger only for specific, high-risk deployments or deviations from standard security baselines, thereby streamlining the approval process for compliant requests. Explanation. Scenario analysis. This scenario presents a common challenge in cloud automation environment where the need for rapid deployment of resources conflicts with the imperative to maintain robust security and compliance. The pressure to deliver services quickly can lead to shortcuts that bypass established security controls, creating significant risks. The professional challenge lies in balancing agility with security and compliance, ensuring that automation processes do not inadvertently introduce vulnerabilities or violate established policies. This requires a deep understanding of the vRealize automation, vRealize, platform's capabilities and limitations, as well as the organization's security posture and regulatory obligations. Correct approach analysis. The correct approach involves leveraging vRealize built-in policy enforcement mechanisms, specifically blueprint policies and approval policies, to integrate security checks directly into the resource provisioning workflow. By defining security requirements as mandatory components of the blueprint and requiring explicit approval for deployments that deviate from or meet specific security criteria, the organization ensures that security is not an afterthought but a fundamental aspect of the automation process. This aligns with best practices for secure DevOps and the principle of shift-left security, where security considerations are addressed early in the development lifecycle. This approach is professionally sound because it proactively mitigates risks by embedding controls within the automation framework, thereby reducing the likelihood of human error or oversight during rapid deployment. It also provides an auditable trail of compliance. Incorrect approaches analysis. Manually reviewing each deployment request before provisioning is an incorrect approach because it negates the benefits of automation, introducing significant delays and increasing the potential for human error. This manual intervention undermines the efficiency gains expected from vRealize and is not scalable. From a regulatory perspective, relying on manual checks creates an inconsistent and unreliable compliance process, making it difficult to demonstrate adherence to security standards. Implementing a separate post-provisioning security scan without integrating it into the vRealize workflow is also an incorrect approach. While post-provisioning scans are valuable, they are reactive rather than proactive. If a non-compliant resource is deployed, the damage may already be done. This approach fails to prevent the initial deployment of insecure resources and introduces a gap in the security posture. It also adds complexity without directly addressing the root cause of potential non-compliance within the provisioning process itself. Disabling all security policies within vRealize to expedite deployments is a critically incorrect approach. This action directly violates security best practices and likely contravenes numerous organizational security policies and potentially regulatory requirements. It prioritizes speed over security, creating a highly vulnerable environment. This demonstrates a severe lack of professional judgment and a disregard for the organization's security responsibilities, potentially leading to data breaches, system compromise, and significant legal and financial repercussions. Professional reasoning. Professionals tasked with managing vRealize automation must adopt a proactive and integrated approach to security and compliance. The decision-making process should prioritize understanding the organization's security policies, regulatory landscape, and the capabilities of the automation platform. When faced with pressure for rapid deployment, the professional should always seek to leverage the platform's built-in controls to enforce policies rather than bypass them. This involves designing automation workflows that inherently incorporate security checks and approval gates. If existing policies are too restrictive for legitimate business needs, the professional's role is to work with stakeholders to refine those policies, not to circumvent them. This ensures that agility and security are achieved in a balanced and sustainable manner, fostering trust and maintaining compliance. Question 13. System analysis indicates that a development team requires the ability to provision virtual machines with specific configurations for testing new application features. To accelerate their workflow, they have requested a self-service catalog item that allows them to deploy these machines without extensive manual intervention. However, security and operations teams are concerned about potential resource overconsumption and the deployment of non-compliant configurations. Which approach best balances the need for self-service with robust security and compliance controls within vRealize Automation 8? 1. Option A. Provide all users with full administrative access to vRealize Automation to allow them to manage their own deployments without restrictions. Option B. Disable all policy enforcement features in vRealize Automation to ensure the fastest possible blueprint deployment times. Option C. Rely solely on user education and manual checks by the operations team to ensure compliance with security policies. Option D. Implement resource quotas and approval policies within vRealize Automation to govern the deployment of virtual machines based on predefined limits and review workflows. The correct answer is D. Implement resource quotas and approval policies within vRealize Automation to govern the deployment of virtual machines based on predefined limits and review workflows. Explanation. Scenario analysis. This scenario presents a common challenge in cloud automation, balancing the need for rapid deployment and self-service with the imperative to maintain security and compliance. The challenge lies in the inherent tension between empowering users with automation and the potential for misconfigurations or unauthorized access that can arise from overly permissive policies. A professional must navigate this by understanding the underlying security principles and the specific capabilities of vRealize automation to enforce them. The risk of a security breach or compliance violation due to a poorly designed blueprint is significant, impacting the organization's data integrity, reputation, and potentially incurring regulatory penalties. Correct approach analysis. The correct approach involves leveraging vRealize automation's built-in policy enforcement mechanisms, specifically resource quotas and approval policies, to control the deployment of resources. Resource quotas prevent users from exceeding predefined limits on compute, storage, or network resources, thereby mitigating the risk of resource exhaustion and associated denial of service conditions. Approval policies introduce a human or automated gate for deployments that fall outside standard parameters or require specific oversight. This ensures that deployments are reviewed against security baselines and compliance requirements before they are provisioned. This approach aligns with best practices for secure cloud operations, emphasizing a layered security model where automation is a tool for enforcement, not a bypass of controls. Incorrect approach is analysis. One incorrect approach is to solely rely on user education and manual oversight. While important, these methods are prone to human error and are not scalable in an automated environment. They fail to provide an automated, auditable control mechanism, leaving the system vulnerable to accidental or intentional policy violations. This approach represents a significant regulatory and ethical failure as it abdicates the responsibility to implement robust, automated controls that are essential for maintaining a secure and compliant infrastructure. Another incorrect approach is to grant broad administrative privileges to all users within vRealize automation. This directly contradicts the principle of least privilege, a fundamental security tenet. Granting excessive permissions increases the attack surface and the potential for unauthorized modifications or deletions of resources, leading to security incidents and compliance breaches. Ethically and regulatorily, this is unacceptable as it demonstrates a disregard for data protection and system integrity. A third incorrect approach is to disable all policy enforcement features to expedite blueprint deployment. This prioritizes speed over security and compliance, creating a direct pathway to potential vulnerabilities. It ignores the inherent risks associated with unmanaged resource provisioning and the potential for non-compliance with internal security standards and external regulations. This approach is professionally irresponsible and exposes the organization to significant risks. Professional reasoning. Professionals should adopt a risk-based approach to cloud automation. This involves identifying potential threats and vulnerabilities, assessing their impact, and implementing controls to mitigate them. In vRealize automation, this translates to understanding the capabilities of the platform for policy enforcement, such as resource quotas, approval workflows, and custom properties that can drive security configurations. The decision-making process should prioritize security and compliance by default, with exceptions requiring explicit justification and approval. Regularly reviewing and updating policies based on evolving threats and regulatory landscapes is also crucial. The goal is to enable agility through automation without compromising security or compliance. Question 14. Process analysis reveals that a critical business application requires immediate deployment to meet a new market opportunity. The IT operations team has identified a pre-approved blueprint in vRealize Automation 8, one that appears to meet the functional requirements. However, the blueprint was last updated over 6 months ago, and recent internal security audits have highlighted increased scrutiny on configurations for sensitive workloads. The business unit is pushing for an expedited deployment, suggesting the pre-approval status should be sufficient. What is the most professional and compliant approach to deploying this application? Option A. Deploy the blueprint immediately, relying on its pre-approval status, and schedule a post-deployment security scan to identify any issues. Option B. Thoroughly review and validate the existing blueprint against current security baselines and compliance requirements before proceeding with deployment. Option C. Deploy the blueprint without further review, assuming that any necessary security updates would have been incorporated into the vRealize automation platform itself. Option D. Develop a new, unvalidated blueprint specifically for this application and deploy it rapidly to meet the business deadline. The correct answer is B. Thoroughly review and validate the existing blueprint against current security baselines and compliance requirements before proceeding with deployment. Explanation. Scenario analysis. This scenario presents a common challenge in cloud automation environments where the need for rapid deployment conflicts with the imperative of maintaining robust security and compliance. The pressure to deliver services quickly can lead to shortcuts that bypass established security controls, potentially exposing the organization to significant risks. The professional challenge lies in balancing agility with security and compliance, ensuring that automation does not become a vector for vulnerabilities. The use of a pre-approved but outdated blueprint for a sensitive workload introduces a specific risk. The blueprint may not incorporate the latest security patches or configurations mandated by internal policies or external regulations. Correct approach analysis. The correct approach involves a thorough review and validation of the blueprint against current security baselines and compliance requirements before deployment. This aligns with best practices in secure DevOps and cloud governance. Specifically, it adheres to the principle of least privilege and defense in depth by ensuring that any deployed resource adheres to the most recent security standards. In the context of VMware vRealize Automation 8.1, this translates to leveraging its capabilities for policy enforcement and blueprint validation. This proactive stance prevents the deployment of insecure configurations, thereby mitigating risks of data breaches, unauthorized access, and non-compliance with regulatory frameworks. It demonstrates a commitment to operational excellence and risk management, which are critical for maintaining trust and integrity in automated IT services. Incorrect approaches analysis. Deploying the blueprint without validation, despite its pre-approval status, represents a significant regulatory and ethical failure. Pre-approval does not guarantee ongoing compliance, especially in dynamic environments. This approach ignores the principle of continuous monitoring and adaptation to evolving threats and regulatory landscapes. It could lead to violations of data protection regulations, e.g., GDPR if applicable, or similar frameworks governing data privacy and security, by deploying systems with known or potential vulnerabilities. Using a newly developed, unvalidated blueprint for a sensitive workload is also problematic. While it might seem agile, it bypasses the established process for blueprint approval and testing, introducing unknown risks. This approach fails to adhere to change management protocols and could result in unstable or insecure deployments, potentially violating internal security policies and compliance mandates. Relying solely on post-deployment security scans to identify issues is reactive and insufficient. While important, it does not prevent the initial deployment of a vulnerable system. This approach is akin to closing the barn door after the horse has bolted and can lead to significant damage before remediation is even initiated. Fails to meet the proactive security requirements expected in professional IT operations and could result in breaches that violate compliance obligations. Professional reasoning. Professionals should adopt a risk-based approach to automation. This involves establishing clear processes for blueprint creation, validation, and deployment, with a strong emphasis on security and compliance at every stage. When faced with pressure to deploy quickly, it is crucial to 1. Understand the potential impact of the workload and the sensitivity of the data it will handle. 2. Reevaluate the existing blueprint against current security policies and regulatory requirements, even if it was previously approved. 3. If a new blueprint is required, ensure it undergoes the full validation and approval process. 4. Prioritize security and compliance over speed when there is a conflict, and clearly communicate the risks associated with any deviation from established procedures. 5. Leverage automation tools like vRealize Automation to enforce policies and automate compliance checks, rather than bypass them. Question 15. Research into the deployment of a new self-service catalog of virtual machines within a regulated financial services organization using VMware vRealize Automation 8.1 has revealed a conflict between the business unit's demand for rapid provisioning of new services and the IT security team's concerns about ensuring all deployed resources meet strict data residency and access logging requirements. The IT security team has requested a delay in the catalog's go-live, until comprehensive security and compliance checks can be fully integrated into the vRealize blueprinting and approval workflows. The business unit is pushing for an immediate launch, suggesting that security checks can be performed manually post-provisioning. Which of the following approaches best addresses this situation while adhering to professional best practices and regulatory expectations for financial services organizations? Option A. Defer the launch of the self-service catalog indefinitely until the IT security team can develop and implement a completely automated security and compliance validation framework for every conceivable service before any user can access the catalog. Option B. Proceed with the immediate launch of the full self-service catalog as requested by the business unit, with the understanding that the IT security team will perform manual security and compliance audits on all deployed resources within the first 30 days. Option C. Prioritize the business unit's request for immediate deployment by launching the catalog with minimal security configurations. The IT security team will then be responsible for retrofitting the necessary security and compliance controls to all provisioned resources as a post-deployment activity. Option D. Implement a phased rollout of the self-service catalog, starting with a limited set of services that have pre-approved automated security and compliance checks embedded within their vRealize blueprints. Concurrently, develop and integrate automated checks for the remaining services, with a clear roadmap for their inclusion in the catalog. The correct answer is D. Implement a phased rollout of the self-service catalog, starting with a limited set of services that have pre-approved automated security and compliance checks embedded within their vRealize blueprints. Concurrently, develop and integrate automated checks for the remaining services, with a clear roadmap for their inclusion in the catalog. Explanation. This scenario presents a professional challenge related to the secure and compliant deployment of vRealize automation, vRA, within a regulated environment. The core difficulty lies in balancing the need for rapid service delivery with the stringent requirements for data protection and access control mandated by relevant regulations. A professional must demonstrate a deep understanding of vRealize capabilities, security best practices, and the underlying regulatory framework to ensure that the automation platform itself does not become a vector for non-compliance or security breaches. The correct approach involves a phased implementation that prioritizes security and compliance from the outset. This includes establishing robust identity and access management (IAM) controls, implementing granular role-based access control (RBAC) within vRealize, and ensuring that all deployed services adhere to predefined security policies and compliance standards. This aligns with the principle of security by design and compliance by design, which are fundamental to regulatory adherence. By integrating security and compliance checks into the blueprinting and deployment pipelines, the organization ensures that automated provisioning inherently meets regulatory requirements, thereby minimizing risk and demonstrating due diligence. An incorrect approach that focuses solely on speed of deployment without adequate security and compliance validation would be professionally unacceptable. This could lead to the provisioning of resources that do not meet regulatory standards for data encryption, access logging, or network segmentation. Such an oversight would represent a direct failure to comply with regulations, potentially resulting in significant fines, reputational damage, and loss of trust. Another incorrect approach might involve implementing security controls in a reactive manner after services have already been deployed. This is inefficient and increases the risk of exposure, as vulnerabilities may exist for a period before being identified and remediated. It also demonstrates a lack of proactive risk management, which is a key expectation in regulated industries. Professionals should employ a decision-making framework that begins with a thorough understanding of the regulatory landscape and the specific compliance obligations. This should be followed by an assessment of the vRealize environment's capabilities and limitations in meeting these obligations. The process involves defining clear security and compliance policies, translating these into vRealize configurations, e.g., policies, blueprints, RBAC, and establishing a continuous monitoring and auditing process. Prioritization should always be given to measures that prevent noncompliance and security incidents, rather than solely focusing on detection and remediation. Question 16. Operational review demonstrates that users are frequently requesting and deploying database servers without adhering to established naming conventions for sensitive data infrastructure, and these deployments are not undergoing any specific approval process. What is the most effective and professionally responsible approach to address this oversight within the vRealize Automation 8.1 environment? Option A. Configure vRealize Automation to enforce custom resource naming conventions for database servers and integrate these requests with a mandatory multi-stage approval workflow based on resource sensitivity. Option B. Implement a single, generic approval workflow that applies to all resource requests, including database servers, to streamline the process. Option C. Disable all approval workflows for resource requests to ensure the fastest possible provisioning times for all infrastructure components. Option D. Instruct users to manually follow the naming conventions and submit requests for manual review by the security team for all database server deployments. The correct answer is A. Configure vRealize Automation to enforce custom resource naming conventions for database servers and integrate these requests with a mandatory, multi-stage approval workflow based on resource sensitivity. Explanation. Scenario analysis. This scenario presents a common challenge in cloud automation environments where resource provisioning needs to align with organizational policies and security best practices. Challenge lies in balancing the speed and agility offered by vRealize Automation with the imperative to maintain compliance and prevent unauthorized access or misconfigurations. A failure to properly govern the deployment of sensitive resources can lead to significant security risks, audit failures, and increased operational costs. The professional must navigate the technical capabilities of vRealize Automation while adhering to established governance frameworks. Correct approach analysis. The correct approach involves leveraging vRealize Automation's built-in policy and governance features, specifically by implementing custom resource naming conventions and associating them with specific approval workflows and resource profiles. This ensures that when a user requests a resource that falls under a sensitive category, e.g., a database server, the request is automatically routed for appropriate review and adheres to predefined naming standards that aid in identification and auditing. This aligns with best practices for secure and compliant cloud resource management, ensuring that sensitive deployments are subject to scrutiny and adhere to organizational standards, thereby mitigating risks. Incorrect approaches analysis. One incorrect approach is to rely solely on end-user adherence to informal guidelines for naming and requesting sensitive resources. This is professionally unacceptable because it introduces a high degree of human error and bypasses the automated controls that vRealize Automation provides. It creates a significant regulatory and ethical failure by not enforcing policies, leaving the organization vulnerable to non-compliance and security breaches. Another incorrect approach is to disable all approval workflows for resource requests to expedite provisioning. This is a critical failure in professional judgment and governance. While it might increase speed, it completely disregards the need for oversight, especially for sensitive resources. This directly violates principles of secure cloud deployment and can lead to unauthorized access, data breaches, and non-compliance with internal policies and external regulations, representing a severe ethical and professional lapse. A further incorrect approach is to implement a single, broad approval workflow for all resource requests, regardless of sensitivity. This is inefficient and undermines the purpose of granular governance. It creates a bottleneck for non-sensitive requests and fails to provide the necessary focused scrutiny for sensitive resources. Professionally, this demonstrates a lack of understanding of risk-based governance and leads to a system that is either too slow or too insecure, failing to meet the dual objectives of agility and security. Professional reasoning. Professionals should adopt a risk-based approach to cloud resource governance. This involves identifying sensitive resource types and implementing specific automated controls within vRealize Automation. The decision-making process should prioritize leveraging the platform's capabilities for policy enforcement, approval workflows, and resource profiling. When faced with a choice between speed and security/compliance, the professional must always err on the side of caution, ensuring that automated guardrails are in place to prevent misconfigurations and unauthorized access, especially for critical infrastructure. Question 17. Stakeholder feedback indicates a growing demand for faster provisioning of virtual machines and applications through vRealize Automation, particularly for projects involving sensitive data. To meet this demand, there's pressure to simplify access controls and reduce the number of approval steps. Given the organization's commitment to data security and compliance, what is the most appropriate approach to balance rapid deployment with robust security and governance? Option A. Disable all vRealize automation policy enforcement features and approval workflows to allow users to provision resources without any restrictions, thereby maximizing deployment speed. Option B. Rely solely on network-level firewalls to secure provisioned resources, assuming that restricting network access will adequately protect sensitive data, regardless of who provisions the resources. Option C. Implement a blanket, allow all policy for all users and groups within vRealize automation, granting them unrestricted access to provision and manage any resource type. Option D. Implement granular role-based access control (RBAC) within vRealize automation, integrating with the corporate identity and access management (EAM) system to define specific permissions for different user groups based on their roles and the sensitivity of the data they will access. The correct answer is D. Implement granular role-based access control (RBAC) within vRealize automation, integrating with the corporate identity and access management (EAM) system to define specific permissions for different user groups based on their roles and the sensitivity of the data they will access. Explanation. Scenario analysis. This scenario presents a common challenge in cloud automation environments where the desire for rapid deployment and self-service clashes with the need for robust security and compliance. The challenge lies in balancing the agility promised by vRealize automation, vRA, with the imperative to prevent unauthorized access and data exfiltration, especially when dealing with sensitive data classifications. The pressure to deliver quickly can lead to shortcuts that compromise security posture, making careful judgment and adherence to established governance frameworks critical. Correct approach analysis. The correct approach involves leveraging vRealize's built-in policy enforcement mechanisms, specifically by integrating with external identity and access management (EAM) solutions and defining granular role-based access control (RBAC) within vRealize. This aligns with best practices for secure cloud operations, ensuring that only authorized personnel can provision or manage resources, and that those resources are configured according to security standards. By enforcing policies at the point of request and deployment, it prevents the creation of insecure infrastructure from the outset. This proactive security model is essential for maintaining compliance with internal security policies and any relevant external regulations that mandate data protection and access control. Incorrect approaches analysis. Implementing a blanket, allow all policy for all users and groups within vRealize is a significant regulatory and ethical failure. This approach completely bypasses any form of access control, leading to a direct violation of principles of least privilege and segregation of duties. It creates an environment ripe for unauthorized access, accidental or malicious data exposure, and potential noncompliance with data privacy regulations. Relying solely on network-level firewalls to secure provisioned resources without any vRealize-level access controls is also a failure. Network security is important. It is a reactive measure. vRealize-level RBAC ensures that the provisioning and management of resources are controlled, preventing the creation of insecure resources in the first place. Network firewalls alone do not prevent a user with broad vRealize permissions from deploying a resource that is inherently insecure or misconfigured, even if network access to it is restricted. Disabling all vRealize policy enforcement features to expedite the deployment process is a direct abdication of responsibility for secure automation. This approach prioritizes speed over security and compliance, creating a high-risk environment. It ignores the fundamental purpose of vRealize's policy engine, which is to automate secure and compliant deployments. This would be a clear violation of any governance framework that mandates security controls for automated provisioning. Professional reasoning. Professionals should approach this situation by first understanding the organization's security policies and any applicable regulatory requirements related to data classification and access. The decision-making process should involve 1. Identifying the sensitive data classifications and the associated security requirements. 2. Mapping these requirements to vRealize capabilities for policy enforcement, RBAC, and integration with IAM solutions. 3. Prioritizing the implementation of granular access controls and security policies within vRealize that align with the identified requirements. 4. engaging with security and compliance teams to validate the proposed configuration. 5. Adopting a phased approach to policy implementation, starting with critical resources and gradually expanding, while ensuring continuous monitoring and auditing of access and provisioning activities. This ensures that security and compliance are integral to the automation process, not an afterthought. Question 18. Which approach would be most appropriate for securely managing sensitive application credentials and API keys within a VMware vRealize Automation 8? One deployment for a new critical application, ensuring both agility and compliance. Option A. Integrate vRealize automation with an external secrets management solution to dynamically retrieve secrets at runtime. Option B. Embed sensitive credentials directly within the vRealize automation blueprint's properties. Option C. Distribute sensitive credentials manually or via an unmanaged shared file system to the deployed application instances. Option D. Store sensitive credentials in custom scripts or configuration files deployed with the application. The correct answer is A. Integrate vRealize automation with an external secrets management solution to dynamically retrieve secrets at runtime. Explanation. Scenario analysis. This scenario presents a common challenge in cloud automation where a new, potentially sensitive application is being deployed. Professional must balance the need for rapid deployment and self-service with the critical requirement of ensuring that sensitive data is adequately protected and that the deployment adheres to organizational security policies and potentially regulatory compliance mandates. The challenge lies in identifying the most secure and compliant method for handling secrets within the vRealize automation (vRA) deployment process without hindering the intended agility. Correct approach analysis. The correct approach leverages vRA's native integration with external secrets management solutions. This is best professional practice because it adheres to the principle of least privilege and avoids hard-coding sensitive information directly into blueprints or scripts. By integrating with a dedicated secrets manager, vRA can dynamically retrieve secrets at runtime, ensuring that credentials, API keys, or certificates are not exposed in version control or accessible to unauthorized personnel. This approach aligns with security best practices and is often a requirement for compliance frameworks that mandate secure handling of sensitive data. It allows for centralized management, rotation, and auditing of secrets, which are crucial for maintaining a strong security posture. Incorrect approaches analysis. Storing secrets directly within the vRA blueprint's properties or in custom script configurations is a significant security and regulatory failure. This method exposes sensitive information in plain text or easily decipherable formats within the automation artifacts. If these blueprints are compromised, stored insecurely, or accessed by unauthorized individuals, the secrets become immediately vulnerable. This violates fundamental security principles and would likely fail audits for compliance frameworks that require secure credential management. Embedding secrets within custom scripts or configuration files that are then deployed alongside the application is also a flawed approach. While it might seem like a way to inject secrets, it suffers from the same vulnerabilities as storing them in blueprints. The secrets remain embedded in deployable artifacts, increasing the risk of exposure. Furthermore, managing and rotating these secrets becomes a manual and error-prone process, increasing the likelihood of security lapses. Using a separate, less secure, or unmanaged method for secret distribution, such as manual distribution or a simple shared file system, introduces significant risks. This bypasses the controlled and auditable mechanisms provided by vRA and dedicated secrets management tools. It is highly susceptible to human error, unauthorized access, and makes it impossible to track who accessed or used which secret and when, leading to potential compliance violations and security breaches. Professional reasoning. Professionals should approach this scenario by first understanding the sensitivity of the data and the applicable security and regulatory requirements. The decision-making process should prioritize security and compliance. This involves evaluating vRA's capabilities for secure secret management, including its integrations with external solutions. The professional should then select the method that offers the most robust security controls, auditability, and ease of management, aligning with the principle of least privilege and the organization's overall security architecture. When in doubt, consulting with security and compliance teams is paramount. Question 19. The review process indicates that a specific group of users is reporting unexpected access to sensitive blueprints and catalog items within the VMware vRealize Automation 8.1 environment, despite their assigned roles not explicitly granting such permissions. The current configuration relies on a combination of vRealize built-in roles and custom roles assigned to these users. Which of the following approaches best addresses this security concern while adhering to regulatory compliance and best practices for vRealize 8? 1. Option A. Modify the underlying infrastructure access controls to grant broader permissions to the service accounts used by vRealize, assuming the issue stems from insufficient infrastructure-level access rather than vRealize role misconfigurations. Option B. Immediately grant administrative privileges to the affected users' roles to ensure they have the necessary access to perform their duties, and then investigate the root cause of the initial access issue in a less time-sensitive manner. Option C. Disable all role-based access control (RBAC) for the affected users and their groups within vRealize until a permanent solution can be identified, thereby preventing any further unauthorized access. Option D. Review and refine the existing role assignments within vRealize, ensuring that the principle of least privilege is strictly enforced. This involves auditing the permissions granted by both built-in and custom roles, identifying any overlaps or excessive privileges, and making necessary adjustments to align with the user's actual job functions. Additionally, leverage vRealize audit logs to trace the access attempts and identify the specific role or configuration that is inadvertently granting the access. Correct answer is D. Review and refine the existing role assignments within vRealize, ensuring that the principle of least privilege is strictly enforced. This involves auditing the permissions granted by both built-in and custom roles, identifying any overlaps or excessive privileges, and making necessary adjustments to align with the user's actual job functions. Additionally, leverage vRealize audit logs to trace the access attempts and identify the specific role or configuration that is inadvertently granting the access. Explanation: the review process indicates a potential misconfiguration within the VMware vRealize Automation (vRealize) 8.1 environment that could lead to unauthorized access to sensitive data. This scenario is professionally challenging because it requires a deep understanding of vRealize security constructs and how they interact with underlying infrastructure access controls, all within the context of a specific regulatory framework. The challenge lies in identifying the root cause of the access issue without introducing further vulnerabilities or violating compliance mandates. The correct approach represents best professional practice because it prioritizes a systematic, least privilege, and auditable method for resolving the security concern. By leveraging vRealize built-in role-based access control (RBAC) and auditing capabilities, administrators can precisely identify and rectify the misconfiguration. This aligns with the principle of least privilege, ensuring that users and services only have the permissions necessary to perform their intended functions, thereby minimizing the attack surface. Furthermore, thorough auditing provides a clear trail of changes, essential for compliance and incident response. An incorrect approach that involves broadly granting administrative privileges to all users or service accounts is a significant regulatory and ethical failure. This violates the principle of least privilege, creating an unacceptable security risk and exposing sensitive data to unauthorized access. Such an action would likely contravene data protection regulations, which mandate appropriate technical and organizational measures to safeguard personal and sensitive information. Another incorrect approach, such as disabling all security controls to fix the access issue, is equally problematic. This demonstrates a severe lack of understanding of security best practices and regulatory requirements, leading to a complete breakdown of the security posture and potential noncompliance with data integrity and confidentiality mandates. Professionals should employ a decision-making framework that begins with a thorough understanding of the reported issue and the relevant regulatory requirements. This involves consulting vRealize documentation and security best practices, followed by a detailed analysis of the current configuration. The process should then move to identifying potential solutions that adhere to the principle of least privilege and maintain auditability. Before implementing any changes, a risk assessment should be conducted, and if possible, changes should be tested in a non-production environment. Post-implementation, Comprehensive verification and ongoing monitoring are crucial to ensure the issue is resolved and no new vulnerabilities have been introduced. Question 20. The analysis reveals that a financial services organization is deploying a new customer-facing application using VMware vRealize Automation 8. 1. The application will handle sensitive customer financial data, and the organization is subject to strict data residency regulations that mandate all customer data must reside within the European Union. The IT team is concerned about ensuring that all deployments of this application automatically adhere to this data residency requirement without manual intervention. Which of the following approaches best ensures ongoing regulatory compliance for this deployment scenario? Option A. Relying on the cloud provider's default region settings and conducting periodic manual audits of deployed resources to confirm data residency. Option B. Training the deployment engineers on data residency regulations and trusting them to select the correct region during the manual provisioning process. Option C. Deploying the application to a default region and assuming that all subsequent data processing will remain within that region without explicit configuration. Option D. Implementing custom properties within vRealize automation blueprints to explicitly define and enforce the allowed deployment regions, coupled with an approval workflow that verifies these properties before provisioning. Correct answer is D. Implementing custom properties within vRealize automation blueprints to explicitly define and enforce the allowed deployment regions, coupled with an approval workflow that verifies these properties before provisioning. Explanation. The scenario presents a common challenge in cloud automation, ensuring that deployed resources adhere to organizational policies and regulatory requirements, particularly concerning data residency and access controls. The professional challenge lies in balancing the speed and agility offered by vRealize automation with the imperative to maintain compliance and security. This requires a deep understanding of how vRealize automation's capabilities can be leveraged to enforce these constraints proactively, rather than relying solely on post-deployment audits, which are often too late to prevent breaches or non-compliance. The correct approach involves integrating compliance checks directly into the service catalog and blueprint design within vRealize automation. This means defining policies, constraints, and approval workflows that are triggered before a resource is provisioned. For example, using vRealize automation's policy engine to enforce data residency by restricting deployment regions, or utilizing custom properties and extensibility to enforce specific access control configurations based on the deployment's purpose or the user's role. This proactive enforcement aligns with the principle of security by design and regulatory frameworks that emphasize preventative controls. It ensures that compliance is a built-in characteristic of the automated deployment process, minimizing the risk of human error or oversight. An incorrect approach would be to rely solely on manual reviews of deployed resources after provisioning. This is a reactive measure that fails to prevent non-compliant deployments from occurring in the first place. It is inefficient, prone to errors, and significantly increases the risk of regulatory violations, as sensitive data might be deployed in unauthorized locations or with inappropriate access controls for a period before detection. Another incorrect approach is to assume that the underlying cloud provider's default configurations are sufficient for compliance. While cloud providers offer robust security features, they are often general purpose and may not meet the specific, granular requirements of an organization's internal policies or external regulations. Failing to explicitly configure and enforce these specific requirements within vRealize automation leaves a critical gap in regulatory compliance. The professional decision-making process should involve a thorough understanding of the applicable regulatory landscape, e.g., GDPR, HIPAA, PCI DSS, depending on the jurisdiction and data type, mapping these requirements to vRealize automation's capabilities for policy enforcement, and designing blueprints and workflows that embed these controls. This includes leveraging vRealize automation's extensibility features, e.g., vRealize Orchestrator, to implement custom compliance checks and integrations with security and compliance tools. Regular review and updates of these policies and blueprints are also crucial to adapt to evolving regulations and organizational needs.